Today we're looking at Glencoe Course 2 Math, Lesson 5.5 on simplifying algebraic expressions. So, when we're talking about simplifying algebraic expressions, that means we're going to take an expression that's nice and long with a lot of different terms, and we're going to simplify it so that we're using the fewest number of terms possible. That means that we're going to we will end up with one term that is numbers only if there's numbers. Okay? If we have variables, we get one term of each variable. That means in our final answer, we only write each variable one time. To be able to do that, we're going to use the properties of expressions that we learned about, like the associative and the commutative and the distributive properties. Yes, ma'am?
Are we on page 388?
We are on page 388, yes. Okay. So, we kind of talked about this before, where we have like terms and we have unlike terms. A like term means that we have the same variable. We're looking at the same kind of thing, but it might be written multiple times.
Oh! Somebody add me in the iMessage group chat when I get home.
If we have unlike terms, that means that our variables are different, or we have one term that has a variable and the other term does not. You cannot combine unlike terms. All right? So, what does that look like? That means, please wait to have that conversation until you're outside. So, if I look at example 1, it asks me to identify the terms, the coefficients, and constants. All right? What we're going to do, we're going to simplify that expression. So if we look at example 1 on page 388, can someone please read that expression to me? Yes, sir.
Identify the terms, like terms, coefficient. 6n minus 7n minus 4 plus n equals 6n plus parentheses.
Hold on. I feel like I made a mistake somewhere. I have 6n minus 7n plus
minus 4.
Minus 4, okay?
Plus n.
Plus n?
Yeah. Equals 6n.
Okay, so our expression, we're looking at the part in bold. So just the part in bold says 6n minus 7n minus 4 plus n.
Oh.
Okay, so this is what we start with. Unfortunately, can I use any properties with the subtraction sign?
No.
No, we cannot. So what should I do to eliminate those subtraction signs? Because I don't like subtraction. I'm going to change it to addition. How do I change that to addition? I'm going to KCA it. What does KCA stand for? Yes, sir.
Keep change additive inverse.
Keep change additive inverse. So, if I'm working with fractions and I'm dividing, I'm going to use the multiplicative inverse. Because I'm trying to add, we're going to use the additive inverse. So, I'm going to start with my first subtraction problem, my first subtraction sign. If I'm going to KCA this, I KCA. Keep the 6n. I'm going to change my subtraction to addition, and my 7n becomes negative 7n. Please hold your conversation until you're outside today. Thank you. So, now I have that subtraction part taken care of. But I have another subtraction problem. So guess what?
What?
We're going to KCA again. That means that this negative 7n, which was the additive inverse, becomes my new k. I keep the negative 7n. I change the subtraction to addition, and my positive 4 becomes a negative 4. Now do I have all addition signs?
Yeah.
Yeah. Okay. I want to put all of my like terms together. Alright? So, if I'm looking for my like terms, we're done. That means that I'm looking for anything that looks the same. Name one type of term that I've got up here.
Oh,
Yes, ma'am.
addition.
Okay, so that's an operation.
Oh.
For my terms, I'm looking for what's a number or what's a part of something that looks like something else. Is there anything that's the same across multiple parts here?
6 and 7.
So those are
N.
numbers. What's
N.
attached to those?
The variable.
N.
The n, the variable n is the same. So anything that has a variable n is a like term. Okay? So I've got 6n, negative 7n, and n. I'm going to end up combining those three things. Okay? So then what do I have left?
4.
Okay, then I have my numbers. My number is different. I cannot combine my 4 with my n's. That doesn't work. So what I'm going to do, I'm going to use my commutative property, which says I can rewrite this problem however I want because I have all addition, to put my like terms together. That gives me 6n plus negative 7n plus n plus negative 4. Everything I started with. Do I still have it here?
Yes.
Okay. Now, can I add 6n plus 7n? No? Okay. I have 6 Nutri-Grain bars. Then, oh wait, I owe you 7 Nutri-Grain bars. So, how many Nutri-Grain bars do I have?
1.
I still have one?
No.
No,
Negative
that's
one.
almost 7.
I have negative 1. I still owe you guys 1.
Oh, you
Okay.
have 0 then.
I have negative 1. I have a negative Nutri-Grain bar. I'm short 1. Okay, but then I get 1 more. So then how many Nutri-Grain bars do I have?
0.
0.
You owe us 1.
What?
You owe us 1.
No, because I got the 1 back to give to you.
You
So-
gave us that 1.
Right, so now I have 0. Okay? So I have 0n. Do I have to write 0n?
Yes.
Yeah.
No.
No.
Wait, 0.
No. I don't have to write anything. I don't have to write anything because all of my Nutri-Grain bars are gone. Okay? I had them. I gave them to you. I was short 1. I got 1. And I gave it to you so that I didn't owe you anymore. You ate them, threw away the wrappers. So it's like they never existed. They disappeared. I don't have to write it.
Interesting.
Okay? I'm left with negative 4. Can I do anything with negative 4? No, I just have to write the negative 4. So, what I have, my constants are numbers. Okay, we know what that quantity is. That's constant. My like terms are 6n, negative 7n, and n, because they all have that same variable. Okay? It doesn't matter if there's a number in front of it. It doesn't matter if that number in front is negative. If it has the same variable, it's a like term. Then I have an unlike term. Okay? Questions before we move on. What property did we use here again? We're guessing the commutative property. Because the commutative property says if I'm adding or if I'm multiplying, I can move it all around as long as everything's still there. Okay? The associative property says I can group things together. The distributive property says I'm going to take one thing and give it to everybody else. Okay? Just like if I'm distributing a quiz. Everybody gets one. Okay? So,
Downtown Florence where
Excuse me, can you please continue that conversation outside of class?
No.
What, Taylor? What is it now?
Alright, I would like for us to look at, let's look at example 3. Can someone please read the problem in example 3 to me?
7x minus 2 minus 7x, plus
Alright.
6
7x minus 2.
minus 7x plus 6 in simple form.
Okay, shh. So, this is what I start with. I'm going to ask you again to continue that conversation once you go outside today. The first thing I'm going to do, can I simplify if I have subtraction signs?
No.
No. So what am I going to do to eliminate that subtraction?
Make it into addition.
I'm going to change it to addition by doing what? Okay. So I'm going to KCA. If I have two subtraction problems next to each other, the additive inverse of one becomes the keep of the next. That can happen, that's okay. Alright? Now do I have all addition? I have all addition now? If I have all addition, now can I combine like terms? I could. What are the like terms that I'm going to combine this time? Okay, so I have my x terms. What other kind of terms do I have that I can combine? Yes, sir?
Numbers.
I can combine the numbers. Alright? Now, are my like terms next to each other?
No.
No. Let's put them next to each other. What property lets me do that? The commutative property. So that gives me 7x plus a negative 7x plus negative 2 plus 6. What is 7x plus a negative 7x?
7x.
Are you
No,
sure?
0.
0x. Do I write 0x?
No, you don't put anything.
Nope, I don't put anything there.
For the x.
If I have 0 x's, I don't write anything. If I write an x, that means that I have one of that variable. I don't have any, so I just leave it off. Okay? What is negative 2 plus 6?
4.
4. Good. So my solution is 4. Ladies and gentlemen, check me in the book. Make sure we did it correct.
Yes.
We got the same thing? Cool.
Yes.
Yes, sir. We got the same thing?
Yeah.
Awesome. Alright, I want to do one more example because in both of these, we ended up with 0 variables. That's not cool.
You got the same number.
Right, and we almost got the same answer. So let's make up another problem where that doesn't happen. Okay? Alright.
We can do 9y minus 4 minus 11 plus 7. 11y plus 7.
Okay, say that for me one more time.
9y minus 4 minus 11y plus 7.
Okay. Shh. Excuse me. We're doing one last example today. Yes, sir. Help me out. What's the first thing that I'm going to do?
You're going to do KCA.
No. I was asking him.
Yeah.
Okay. What are we going to do first?
KCA.
I'm going to KCA. How many times do I need to do that?
2 times.
Twice, because I have subtraction twice. Okay. 9y, I change the subtraction to addition. The additive inverse of 4 is
Not 5.
negative 4. Okay. I keep the negative 4. I change the subtraction to addition. The additive inverse of 11y is negative 11y. Okay. Now what am I going to do?
Add.
What can I add?
9y plus, no, you're gonna do 9.
I'm going to rearrange my problem. Okay, what property lets me do that starts with a C?
Associate.
The commutative property. So I have 9y plus negative 11y plus negative 4 plus 7.
So y'all think y'all sweet.
Please continue that outside. Yes, sir.
Is that 11y?
Yes. Okay. Ukulele starts with a U, but yeah, we can have ukuleles today. Alright. 9 ukuleles. Then I owe 11 ukuleles. How many ukuleles do I have left?
3. Negative 0.
2.
2. Okay? So I still owe 2 ukuleles, or 2y. So that's negative 2y. Negative 4 plus 7 is?
3.
3. Can I combine
No.
owing 2 ukuleles and 3?
Yes.
No. So this is my final answer.
Cause I just said you got a big deal.
Thank you.